Okay, let's have a class. We're going to move on to the exam 4. Exam 4, we basically have 4 lectures. So it's pretty short and pretty simple. We talk about applied microbiology. So the outline will be first, we talk about food microbial safety in the United States. The second one, we're going to talk about W, West Virginia, WV, poultry processing, and some of the pathogen relations act. Number 3, we're going to talk about basic immunology. And the last one we're going to talk about is virus. This will be short. Then we had a review. Okay, that's pretty much our 4th section. Then we had a final exam. Now, remember, the final exam is not accumulated. So it's not accumulated for everything. It's just the final section. Okay, so I also call it an exam 4. Now be careful, there is something I would like to remind you. If you're doing very well so far, you should keep doing the same thing. Some of you have extra points, did very well in the exam 3. And you get maybe after the final exam of lab notebook check and everything, you may need only like 40 points to get an A. But I hope you still keep the same to study hard. And don't calculate how many you need and give me like almost empty paper on the final exam. So that's something suggestion for the good students. But also I have some suggestions to some people didn't do very well. Please keep studying and keep doing your best. Because we still have 30 points for final exam, extra points for writing a short thesis. I'll put the title on the eCampus real quick so you can prepare it. And we still have a final exam, so I have some questions.
Is there an A+ in the base?
I usually don't do A+, I do A-. People get 550. This, between these, we'll give you like A-. I usually don't do A+, because it's hard to do it. And what happened is, we had 30 points of the extra thesis writing. Then in the final exam, we still have like 10 points, maybe extra points. At the lab final exam, we still gave you some 3 or 5 points of extra points. So you still have to study. There's a bunch of points there for grab. And also this makes your life a little bit easy, you know what I'm saying? So please doing that, okay? Don't give up. Because it's very easy. At the end of the semester, we have 2 different directions. Some people very good, also doesn't care too much. Some people not very good, you also give up. Then at the end of the day, it won't be too good. Okay, so just have some hands on. The first section, we're gonna most time stick to the slides. And I also had a very good Zoom recording of this section because I gave a guest speaker talk last year for University of McGill University in Canada, when I gave as a guest speaker there, talk about food safety in the United States and some of my research extension activities. So at the end of the semester, I always introduce myself a little bit of the research what I did in the lab, since my majority of the course we already talked about the knowledge. So first of all, what is the whole situation of foodborne illness in the United States? We have 2 surveys coming from CDC, Centers for Disease Control and Prevention. So first of all, you need to know what is CDC. Centers for Disease Control and Prevention. That's called CDC. They have a surveillance to talk about the foodborne illness in the United States. Look at the older one. In 1990, almost 20 years ago, 75 million illness per year. End up with 323,000 hospitalization, 5,000 deaths, and it cost 8.4 billion. Now, 10 years later, in 2011, you can see the illness per year is dramatically decreased to only 48,000. Hospitalization decreased more than half, end up with 128,000, and death is 3,000, and the cost in the opposite direction, which is increased to 77.7 billion. Now, why everything else is decreased? Except for the cost, the cost of the medical is increased. But how come the illness hospitalization is decreased? Because we did a lot of work from the federal government standpoint. They regulate all the small processors, even the small processors has to be established a hazard plan, hazard analysis critical control points plan. And they have the new FISMA comes out in 2011. And then they have three alternatives for control Listeria monocytogenes or ready-to-eat meat. So all kinds of different prevention strategies are existed in the United States food supply chain, always all the way from farm to the table. That's why the foodborne illness is dramatically decreased. So we are in the right direction. Now, what are the important foodborne pathogens? We already mentioned some of them. Now, basically, norovirus. There's one outbreak happens in Yellowstone, Wyoming, which is in 2013, I believe so. There's 100 people who just eat something and they have a diarrhea, vomiting, and including the kids. It's a norovirus. Now, Campylobacter and the Salmonella is most likely going to focus on the poultry products. We will mention on Thursday more detail. E. coli 0157 and non-0157 Shigella toxin generate E. coli. STEC, which means Shigella toxin generate E. coli. This is Shigella toxin E. coli. That's STEC. It is important for the ground beef and the non-intact beef. Listeria monocytogenes basically is for ready-to-eat meat. Clostridium botulinum, you know that botulism, infant botulism, wood botulism, and food botulism for canned food. Shigella, we already mentioned, they care kids, but this could be the foodborne pathogen, toxoplasma, and some emergent organisms. Okay, now there is a debate to talk about the COVID-19. Is that a foodborne pathogen? No, it's not. But also, although people isolated from the frozen foods all the time, especially like a seafood. So we're going to talk about these a little bit of detail, all these things. This is some of the survey results. The top 5 pathogens cause domestic acquired foodborne illness is right here. Number 1 is norovirus, followed by salmonella. It's a non-typhus. Clostridium perfringens, then Campylobacter and Staphylococcus aureus. And the percentage you can see is decreased from 58, 11, 10, 9 to 3. All of these combined together is responsible for 91% of the foodborne illness in the whole United States. Okay, which one will cause hospitalization? Which means which one will end up with people going to hospital? And you know hospitalization is expensive in the United States. You stay one night, maybe give you $1,000 bill sometimes. So people do some of the surveillance. Number 1 is salmonella. Number 2, norovirus, followed by Campylobacter. And I'm very surprised the Toxoplasma gondii. That because maybe people have cats at home, because it's a parasite. The host is a cat. Last one, E. coli 0157 H7. Add up them together, responsible for 88% of the whole foodborne illness, resulted hospitalization in the United States. What are the top 5 pathogens cause deaths? This is more severe, we are more care about. Number 1, salmonella. So always remember the number 1 causing deaths regarding foodborne pathogen in the United States is salmonella, followed by Toxoplasma gondii. Listeria is one of them, Listeria monocytogenes, 90%, can you see 90%? Norovirus and Campylobacter. So when you eat a chicken products, be careful. Both of these together is 34% of the deaths happens in the United States per year. Both Campylobacter and salmonella relate to the poultry meat products. So we're going to do an overall conclusion for the concerns. Now, of course, every food product could be contaminated with all kinds of foodborne pathogens. But what are they mainly targeted? For fresh meat, we care about Salmonella campylobacter, E. coli O157H7, and non-O157 Shigella toxin E. coli. How about the ready-to-eat meat and poultry, like ham, beef, franks, and the hot dogs, turkey breast? We care about these Listeria monocytogenes. How about fruits and vegetables? Salmonella, E. coli, norovirus. Those are the target. That means in my areas, there's a lot of the research talk about the pathogen control, and these are the target for the reservoir. Need to do the more research about that. So let's talk about these a little bit. Listeria, first of all. Listeria, there's 6 species. Listeria monocytogenes, Listeria inoca, Ivanovia, Silegra, Wishimeri, and Grani. We care much about these Listeria monocytogenes. And you can see what happens is a beta hemolytic on a blood alcohol. Now, Listeria inoca, we do sometimes using it as a surrogate of a pathogen. Surrogate. So what happened is, in the food processing plants, we can use a pathogen. If you do a several inactivation study, a validation study for the hot dog in the meat plants, you can put Listeria monocytogenes. For some of the small meat plants, it may be let you use some of the surrogate, which means their behavior should be more resistant or the same as the targeted pathogen. So ideally, Listeria inoca should be behave more heat resistant or normal compared to Listeria monocytogenes is on the turkey breast or hot dog during the cooking process. So what is Listeria? So let's talk about a little bit more. It's gram-positive. It's a Petrotrichus flagella. Remember, Petrotrichus, it had a very strong motility, can go everywhere. It's a facultative anaerobes, which means it grows both in the presence or absence of oxygen, grow better with oxygen. It's a hemolysin positive, which means it can lysis hemo cells, red blood cells. That's for Listeria. Now, Listeria has another thing I want to mention, very important. Listeria, this bacteria, can grow in a refrigerator temperature. This guy, we also call it a cyclophile. 2 cyclotroph. If you still remember this terminology in the exam 1, they could grow 0 to 5 degrees Celsius, which means they can grow in the refrigerator. That's why it is a risk for the ready-to-eat meat. Because if you had a hot dog, is that right? You vacuum package it. You vacuum package, you put in the refrigerator, you think all the oxygen is gone. So bacteria and the foodborne pathogen will not grow. No, it's going to grow. Because even at 5 degrees Celsius, this guy going to grow. And I tell you, when things grow very well, it can grow from 2 to even 8 log after like 90 days. So if they contaminated in the refrigerator temperature 90 days, 3 months, it can grow like 8 logs. So that's a risk. That's why it is a risk for this ready-to-eat meat. Now, what do we care about that? Well, of course, Listeria monocytogenes, there's a lot of species. The strains are different, and their serotyping are different. There are certain serotypes. And there's 95% of them are coming from 0.5A, 0.5B, and 4B. And in the North America, which means in Mexico, United States, and Canada, the cerebral 4B accounts for 65 to 80% of Listeria monocytogenes strains. It's a huge, okay? More. Listeria monocytogenes grow. What they have to grow? They grow very dramatically in all these support media, BHI, TSB, TSBYE. What is TSBYE is you're adding yeast extract into the TSB solution. So TSBYE is tropic soil broth, you're adding yeast extract. Then become TSBYE. Once you add this word, it will grow more dramatically. Now, you sometimes need vitamin B and amino acids. They can grow in 10% salt. What that means, which means it's resistant to the salt. It's a halophile. That's why it's a risk for these hot dogs. Remember the hot dogs, how many fat are there? How many salt? 5% salt. How many fat? 12% fat. So no problem. You have a salt, it's going to grow. Because of Listeria monocytogenes. Yes?
I didn't mean to interrupt. You can finish. I had a question about Listeria. I was reading. Are you familiar with the Lysol spray? Lysol.
Yes.
It kills 99% of bacteria. On the back of the Lysol spray, it reads, "It kills Listeria." Lysol. Yeah, it says it kills Listeria.
Now, what is Lysol? What's the components of the Lysol? Do we have it? What it has? Ammonium chloride. Yeah, ammonium chloride. Benzo ammonium chloride.
So, like, you wouldn't spray that on your chicken, on your food, right? So, if Listeria is only like a foodborne illness, right? Why would you want a Lysol to kill Listeria if you're not going to spray your food with it?
Okay, I have that's a very good comment. So, Listeria monocytogenes is not only the foodborne pathogen. That could be go everywhere.
Okay.
It could be in the fresh produce. Remember, I will talk about real quick. In 2012, there is a Jason farm in Colorado. The cantaloupe has been contaminated with Listeria monocytogenes. So not only in the ready-to-eat meat, it could be on the floor. Originally, it's also coming from the soil. So now, when you're regarding, we're going to talk real quick about the 3 alternatives for the hot dog. All those chemicals has to be approved by FSIS. They can be safely used on the surface. It does not mean you can just wipe the Lysol on the ready-to-eat meat, then back in package. Okay, so that's a very good point. Let's say on the bench you may have a Listeria there, could be also, on the soil, on the floor, and also right now, recently, Listeria monocytogenes is also an emergent pathogen for the poultry meats. Because people get lots of in the poultry farms also. And it's under-researched, unrecognized pathogen. So it's everywhere, But you have a good point there. Now the pH range from 4.1, 9.6, a little bit alkaline can survive. Wide range of the temperature, 0.5 to 3 degrees Celsius. This gives you trouble. Okay. It also can grow at lower water activity, 0.9 to 0.92. What is the water activity of those products? Do you know if you end up with water activity, that level low, that's not high, what is that? Beef jerky. Kind of the fresh beef jerky. And what are the products? Salami. Some sausage. These products, these are also fresh. Okay, if you put it longer, it's not going to be that high. It's going to be very low. Salami, some sausage, lactic acid, the fermented products, the pH, the water activity is lower. Usually the bacteria will not grow. Listeria will grow. So overall, you can see Listeria monocytogenes is actually resistant to a little bit high salt, refrigerated temperature, and lower water activity environment. So it's very, I would say it's almost everywhere, pretty much resistant to the otherwise environments to grow. This is a big deal. Why it's a hot topic? Back 20 years ago, from 1998 to 2000 to 2002, this is the multiple states outbreak. You add up them together, almost 200 cases. How many people died? 35 people deaths. Now, Listeria monocytogenes will cause miscarriage and stillbirths. It's involving the whole 42 states. We have 50 states, is that right? 42 states have it. It's caused like almost like $10 million got lost on the meat industry because of raising meat outbreaks of Listeria monocytogenes. So we need to do something. Back in 2003, which is right the outbreak happens, FSIS and the FDA work together, come out with 3 alternatives to control Listeria monocytogenes. What are the 3 alternatives? Number 1, we call it post-lacellative treatments with antimicrobials. What is the post-lacellative treatment? Post-lacellative treatments, which means after you cook it, that one could be the UV lights. Could be you using vacuum package. That's a post-lacellative treatment. Now, what are the antimicrobials? Lactic acid is one of them. Citric acid is one of them. When you look at the label, sodium diacetate is one of them. Then you see potassium lactate. That's one of them. These are the chemicals, are major, especially these 2. Now, right now, they are talking about the clean label. So have some new antimicrobials comes out. I did the research a long time ago about hops beta acids. That's used for the beer brewing. I published like 3 papers there, 4 papers there. Because they want you to do the research to see the impacts for the post-lacellative treatments with antimicrobials. Second one is simple. Post-lacellative treatments or not and or antimicrobials. How about the last one? If you don't want to do anything, that's okay. But you have to do SSOP, Sanitation Standard Operation Procedure, and do a more frequent sampling, and we call it testing. But you always remember, testing negative does not mean food safety. Because food is a matrix. It's very difficult that you're going to sample everything. Let's say you had 10,000 hot dog in the plants. Are you going to take every hot dog like the lab, you shake it, you do like this, and you test the bacteria? No. They are based on is a statistical analysis. That's called class 2 and class 3. I would say it's a rejection model. This is, I'm going to not talk too much here because this is another class, which is food microbiology. And Dr. J is teaching that in the spring semester. If you're interested, you can take in this class. And in our division, that's talk about how the sampling. So remember, for the sampling, do the testing does not mean food safety. This does not mean at all for food safety. Okay? Therefore, when I was student 20 years ago, 15 years ago in Colorado State University, I did lots of research for my PhD. Part of them is for post-lacellative treatments and antimicrobials for Listeria monocytogenes control on the hot dogs. What is the impacts of that? Look at 2011, 10 years later, almost 80 years later. Listeria still causes 1,600 full-blown illness, 1,500 hospitalization, 260 deaths in the United States annually. It's still happening. Because although you use these treatments, there's always something new to come. And you always remember antimicrobials, it's only inhibit bacterial growth. It's not going to kill it. So which means we have a bacteriostatic impact, but not bactericidal impacts. Okay? Next one, we're going to talk about E. coli. First of all, most of E. coli is generic, not pathogenic. Remember, I write there on the blackboard at the very beginning of the class, when we talk about the E. coli, we have to be careful. Some of them are pathogen. What are these four categories? enterotoxigenic E. coli, enteropathogenic E. coli, enteroinvasive E. coli, and enterohemorrhagic E. coli, which is EHEC. Therefore, there is some story we're going to tell you. Regarding the E. coli, it's a big story. That is a dramatic happens to change everything in the United States for the food safety. I will say that. If this one doesn't happen, we cannot imagine if today the food may not be still safe. E. coli 0157H7. What is O? Ceramic, O antigen. What is H? Flagella, serological typing. We mentioned again in the immunology part, okay? This one, in 1982, they started in Oregon, has a small outbreak. Originally coming from cattle. And it's a fecal sample contamination. Nobody cares. Now, what the symptoms it will have? The symptoms will cause hemorrhagic uremic syndrome, which means blood kidney with water diarrhea, and sometimes will be touching nerves, which is neurological symptoms. Could happen. It depends. Nobody cares. You just have some diarrhea, have some blood kidney. This is really bad. In 1993, Jack in Box in Seattle, the undercooked hamburger cues for kids. And I tell you one thing, it's always the same. If those 4 kids is not sacrifice their life, nobody will care anymore, to be honest. And because of this, it's touched the nerve of the White House. Who's the president at the time? Bill Clinton and Al Gore. They started to work to do something, try to do something. Then, had this one comes out. Had this HACCP plan comes out. And I worked in Seattle 1 year, in 2010, we are just graduate. The company there called IEH do the testing. The boss there, he originally is a professor in Washington, University of Washington. Because of this outbreaks, he started to do the